Just like that.
Yeah, it looks good.
Yeah, great. So, hello everyone. I'm Shai Almog, and today we'll talk about debugging at scale in production, specifically about Kubernetes debugging. And when I say Kubernetes debugging, I don't mean debugging Kubernetes itself, but rather an application running in Kubernetes. So I'm assuming everyone here knows the basics of Kubernetes. So I will dive right into the basic problem description and then into the 3 tools that I will show today. But first, a few things about me. I was a consultant for over a decade, worked at Sun, founded a couple of companies, wrote a couple of books, wrote a lot of open source code, and I currently work as a developer advocate for Lightroom. My email and Twitter accounts are listed here, so feel free to write to me. I have a blog that talks about debugging and production issues at talktotheduck.dev. It would be great if you check it out and let me know what you think. I also have a series of videos on my Twitter account called the 140-second Ducklings, where I teach complex things in 140 seconds. The current series is based on debugging, and it covers a lot of things most developers don't know about and would find helpful. I'd really appreciate if you check it out and let people know about it. Also, for those of you late to join in the chat, there's Tom Granot, who can help you with questions if you have things during the presentation, thoughts, complaints, etc. So he's more than qualified to answer that. So containers and orchestration are, wait a second, this whole, bloody hell. That whole Zoom here is giving me a tough time here. So excuse me for a second. I need to move this around a bit and go back. So sorry.
Oh, good.
I was
Screen sharing
hiding my
looks good.
slides completely there, so forgive my. There we go. So containers and orchestration revolutionized development and production. Really, no doubt. But in a way, Kubernetes made debugging production issues harder than it previously was. In the past, we had physical servers we could just work with, or even VPSs. Now we face a much greater difficulty in this age due to 3 big challenges. The massive scale enabled by Kubernetes is a huge boon, but it also makes debugging remarkably difficult. We need new tools to deal with the scale. We now have multiple layers of abstraction at the deployment level, where failures can happen in the orchestration, container, or code layers. Each failure requires a different set of skills and solutions. Tracking the cause to the right layer isn't necessarily trivial. Finally, there's the barebone or lead deployment problem when debugging. This is the first problem I want to focus on. We'll get to the other 2 soon enough. It's the problem of the bare naked container. We can connect to a barebone container, but we have nothing to do inside it. Nothing is installed. We can inspect logs, but that relies on luck. Furthermore, if your logs are already ingested by a solution like Elastic, you probably don't have anything valuable to do within a barebone container. kubectl debug solves these problems and can work even with a crashed container or a barebone image. The kubectl debug command adds ephemeral containers to a running pod. An ephemeral container is a temporary element that would vanish once the pod is destroyed. With it, we can inspect everything that we need in the pod. Most changes we do in it don't matter. They won't impact the pod after we're gone. It works with the barebone container, The way it does this is with a separate image. So we can have an image that includes everything in it. The container spun from the image is ephemeral and can include a proper distro, not proper in a sense, and the set of tools that we need to debug. kubectl debug was introduced in version 1.23. So if you're still in an older version, you will need to wait for that. If you use hosted Kubernetes, you need to check the version that they use. So let's start with a simple demo. As you can see, we have here a few pods. We're experiencing an issue and would like to increase the logging level so we can better see what's going on. I can use exec and log in directly to the live pod. I log in with a proper bash shell. I'm sure most of you did that in the past, and it's pretty easy. Here I can just use standard commands like cat and grep to check the logging level. This is all good. We can see the current level is at info. Unfortunately, I don't even have Vim if I want to edit this file. Now, when the container has apt or APK, and when the pod doesn't crash, I could, in theory, just apt get install Vim. But that's got its own problems and is a painful process. We don't want people in production just installing packages left and right. Even if it's cleaned up, the risks are sometimes too high. Pods shouldn't be touched in production. Once deployed, all the information and state of a pod should be described in its manifest, unless it's a strictly stateful pod like a database, etc. So installing like this is problematic. So let's exit for a moment and try connecting again with the kubectl debug. I'll use the busybox image in this case, and we'll see how that works. Notice that this is the image referenced in the kubectl debug docs. So I'm connected to the pod again, or so it seems. Technically, I'm connected to a new ephemeral container and not to the pod directly. This is an important distinction. But as you can see, again, I don't have Vim or really any of the tools I would expect, like Visual VM, Traceroute, etc. I can fix that. I can create an image that represents everything that I need and package all of the tools I need. Then pass that image to kubectl debug and just use these tools. But here's the thing. I'm not a unique snowflake. We're all pretty much the same. We all expect the same things in our debugging sessions, and that image I can use is probably the same image you would use. So why not have one generic image for all of us? This is where KoolKits comes in. KoolKits was created by Tom Granot of Lightroom, who, as I said before, you should see in the chat right here, clap. KoolKits is an open source project that includes a set of opinionated, curated, platform-specific tools for kubectl debug. So you can have everything you might need at your fingertips while debugging. So what does that mean? When you use kubectl debug to spin up an ephemeral container, it's built using a KoolKits image. Currently, there are 4 standard images. A Go image that includes tools such as Delve, pprof, Go, Calvis, and many others. The JVM toolkit, which includes tools such as SDKman, JMXterm, Honest Profiler, Visual VM, and much more. The Node version includes NVM, NDB, 0x, VTOP, and again, much more. And finally, the Python version includes PyEnv, IPDB, IPython, and again, much more. But this is just the tip of the iceberg, as all the versions include the many tools you would expect in any proper debugging session, such as Vim, HTOP. We even have a lot of networking tools like traceroute, Nmap, database clients for Postgres, MySQL, Redis. Again, so much more. So let's continue from where we left off in the demo. We can disconnect from the current session and then spin up a new session with the KoolKits image. Notice we can also use the shorthand KK command for many operations, which I don't use here, but you can see the syntax in the KoolKits docs. Specifically in this case, notice I used the JVM version of KoolKits, which I chose because I'm a Java guy. But if you're using a different environment, you can use what fits there. In KoolKits, pretty much every tool I want is already pre-installed as part of the image by default. This means we can just connect and everything is already there. Since we're all very similar in our needs, KoolKits includes the common things most of us need based on the platform or language. It has sensible defaults and comes with Ubuntu as the distro. This is important. You have a full distribution like you would have in a desktop or in a regular server. This is very helpful for debugging. So you get everything you need, even when debugging bare-bone container. Notice that thanks to kubectl debug, we have full access to the main application's containers file system and the pod's process namespace as well. So we can do everything there while residing in a more convenient environment. It's literally having our cake and eating it. So to finish the story from before, I can just use Vim to edit the file and change the logging level to error, which I can then confirm using cat and grep. I can also do a lot of other things, such as profile using a profiler, debug with GDB or JDB. I can use JMX term to perform JMX operations, which lets you configure the way the JVM behaves in runtime, and pretty much anything I can do in a local machine. To give you a sense of what KoolKits installs, this is the list of packages for the JVM client. And this is bound to grow as you can all submit pull requests with your favorite packages to any one of the existing KoolKit projects, or even to a, dare I say, a new KoolKit image that fits a new platform. So this is just the JVM specific image. The other images contain similar tools at a similar scale, and you can get all that thanks to kubectl debug and KoolKits. What if what we're tracking seems to be an application bug? This is a common occurrence for sure. We might not know it at this stage, but that might be the place we want to investigate. We can try using logs and probably should start there. But more often than not, the issue we need to solve aren't logged, sorry. We can try using various observability tools. They're great. No doubt, they're great. But not for application level issues. They rule for these big picture analysis and container level problems, not for application level problems. We can use one of the debuggers in KoolKits to track it. That would only work if we know the server where the issue manifests, which we sometimes do know. It is remarkably risky connecting a debugger to a production environment. And it can lead to multiple problems. Stopping on a breakpoint by accident, using a conditional statement that grinds the system to a halt, exposing a security vulnerability. It's risky. Finally, there's remote debugging. such as JDWP in this example, because we're talking Java, obviously, as I said, Java guy. And JWP stands for Java Debugging Wire Protocol. There are several such remote debugging protocols that we can use. It suffers from similar issues, but I think it's best explained with a demonstration. So here's the first problem we run into with a debugger. We can't just start using it. We need to relaunch the app with debugging enabled. That means killing the existing process and running it over again. That might not be something you can just do, you know. Furthermore, running in this mode is a big security risk. Notice I limit access to only the local server, but still it's a big risk. Leaving a remote debugging port enabled in a deployed server code is considered a huge security vulnerability. If hackers can ride a different vulnerability, they might be in a position to leverage this from a local system. Still, if we do this for a short period of time, this might not be a big deal, right? So let's try it. In a different window, I need to find the process ID for the application I just ran, so I can connect to it. I can now type it into the JDB command, and now I am connected with a debugger. I can add a breakpoint using stop at command. Naturally, I need to know the name of the class and the line number, but I can set a breakpoint to stop at. Once stopped, I can step over like I can with a regular debugger. However, this is pretty problematic, a pretty problematic notion on multiple fronts. First off, I'm literally stopping the threads accessing the application. That's probably not okay on any container you have in the cloud. There are ways around that, but they aren't trivial. The second problem is different. I'm old, so people automatically assume I love the command line. And I do to some degree, but I love GUI more. When I started programming, there was no option. I started programming in the 80s, by the way, older than I look, early 80s. We didn't have IDEs on Sinclair or Apple II or PDP. But now that we have all of those things, well, I don't want to go back. I programmed Java since the first beta, and this was actually the first time I used JDB. I literally never used it before. I'll use command line tools when they give me power. I mean, I'm not afraid of bash, fish, etc. I like them to some degree. But debugging via commands, I just can't. The obvious answer is JDWP. We have a remote debug protocol that's supposed to solve this exact problem, right? But this is a bit problematic. If we open the server to remote access with JDWP, we might as well hand the keys over to the office to hackers. A better approach is tunneling. Now, during the age of VPS, we could just use SSH tunneling, like this. We'd connect to a remote host and forward the port where the debugger was running locally. Notice that in this sample, I used port 9000 to mislead hackers scanning for port 5005. Although it won't matter because it's SSH, it's good. We can do the exact same thing with Kubernetes using the port forward command to redirect a remote JDWP connection to a local host. Port forwarding opens a secure tunnel between your machine and the remote machine. And on the given port, So when I connect to localhost on the forwarded port, it seamlessly and securely connects to the remote machine. Once we do that, I can just open IntelliJ IDEA and add a run configuration for remote debugging, which already exists and is pre-configured with the defaults, such as port 5005. I just give the new run configuration a name, and we're ready to go with debugging the app. Notice I'm debugging on localhost, even though my pod is physically remote. That's because I'm port forwarding everything. I make sure the right run configuration is selected, which it is. We can now just press debug to instantly connect to the running process. Once that is done, this feels and acts like any debugger instance launched from within the IDE. I can set a breakpoint and step over and get this wonderful debug GUI I'm pretty much used to. Perfect, right? Well, not exactly. It's got quite a few of drawbacks still. As we can see, there are so many problems in this process. First and foremost is the need to restart the process. We can possibly run with debugging turned on by default, but that is a huge risk. Then it's breakpoints. They break. I heard a story years ago about a guy who debugged a railed system, and it literally fell into the ocean while he was stopped on a breakpoint because it didn't get to the stop command. I don't know if that's an urban legend, but it's totally plausible. This is true for all remote debugging protocols, but I can personally attest about JDWP, which I'm familiar with. It's very insecure. In fact, there are CVEs already about products that left it open. It isn't designed with security in mind, but it's also a stability risk. How many times did a debug process crash on you? Imagine adding a breakpoint condition that's too expensive or incorrect. It might destroy your app in production. Just loading the variables in the watch can cause unforeseen problems in some cases. But this is the absolute worst. Say your app has a place where it takes user credentials for logging in. Maybe a third-party library you use does that. You can still place a breakpoint right there and steal user login details. Worse, you can elevate the permissions of your own user account because everything is writable. Just set the value of a variable. This goes against pretty much every privacy law and is damn likely. 60% of security breaches in organizations happen because of an employee. There's often a misconception of security that targets the outside world only. This just isn't true. If you do that, if you enable debugging locally directly in Kubernetes, you're effectively exposing your system completely to a malicious employee. I didn't forget about this slide. This is an even more important aspect. Everything we discussed up until now assumed we know the exact container where a problem is happening. In real life, this is rarely the case. We can have thousands of containers in the real world deployments. How do you debug something like that? The debugger can solve depth issues really well. It can get to a deep line of code. It can place a breakpoint really, really deep and on a specific line. But it can't debug scale. It can't place a breakpoint on all the servers. And if it could, you wouldn't be able to handle that. So it was built for depth, but it wasn't built for scale, and it very much wasn't built for production. That's where developer observability comes in. We used to call this continuous observability, but developer observability makes more sense. It's a new set of tools designed to solve this exact problem. Observability is defined as the ability to understand how your systems work on the inside without shipping new code. That without shipping new code portion is key. But what's developer observability? With developer observability, we don't ship new code either, but we can ask questions about the code. Normal observability works by instrumenting everything and receiving the information. With the developer observability, we flip that. We ask questions and then instrument based on the questions. So how does that work in practice? In practice, we add an agent to every pod. That lets us debug the source code directly from the IDE, almost like debugging a local project, but designed for scale. To start, we need to sign up for a free Lightroom account at lightroom.com/free. Notice that Lightroom has a very generous free tier you can use to experiment with this product. I'm talking here about Lightroom because my, well, obvious bias, but pretty much everything I say applies to other developer observability tools in the market, although I'm bound to say that ours is by far the best and most functional, so I might be biased. Pretty much everything I show here can be accomplished in the free account. I'll skip the actual setup since it's covered there and we don't have all that much time left. You can check the Lightroom docs for more detailed instructions on setting Lightroom in Docker, Minikube, etc. Unlike kubectl or debug, we need to install the agent before the problem occurs. So if we do run into a problem, we'll be able to jump right in. Let's skip right ahead to a simple demo right in the IDE once the agent is set up. This is the prime main app in Kotlin. It simply loops over numbers and checks if they are prime numbers. It sleeps for 10 milliseconds, so it won't completely demolish the CPU. But other than that, it's a pretty simple application. It just counts the number of primes it finds along the way and prints the result at the end. We use this code a lot when debugging since it's CPU intensive and yet very simple. In this case, we would like to observe the variable I, which is the value we're evaluating here, and print out CNT, which represents the number of primes we found so far. The simplest tool we have is the ability to inject a log into the application. We can also inject a snapshot or add metrics. I'll discuss all of those soon enough. Selecting log opens the UI to enter a new log. I can write more than just text. In the curly braces, I can include any expression I want, such as the value of the variables that are included in this expression. I can also invoke methods and do all sorts of things. But here's the thing. If I invoke a method that's too computationally intensive, or if I invoke a method that changes application state, the log won't be added. I'll get an error. After clicking OK, we see the log appearing above the line in the IDE. Notice that this behavior is specific to IntelliJ or JetBrains IDEs. In Visual Studio Code, it will show a marker on the side. Once the log is hit, we'll see logs appear in batches. Notice I chose to pipe logs into the IDE for convenience, but there's a lot more I can do with them. For now, the thing I want to focus on is the last line. Notice that the log point is paused due to high call rate. This means additional logs won't show for a short time, since logging exceeded a threshold of CPU usage. This can happen quickly or slowly, depending on how you're observing. Let's move on to a different demo. This is the Node.js project that implements a backend of a microservice architecture. This is a method that gets invoked when we click a movie and want to see the details. This time, I'll add a snapshot. Some other developer observability tools call this a capture or a non-breaking breakpoint, which to me sounds weird, but the idea is usually the same. Once I press OK, the camera button appears on the left, indicating the location of the snapshot, like you would see with a regular IDE breakpoint. Now I'll just access the portion in the front end that triggers this code. And now we wait a second and the snapshot is hit. So what is the snapshot? It gives us a stack trace and variables, just like a regular breakpoint we all know and love. But it doesn't stop at that point. So your server won't be stuck waiting for you for a step over. Now, obviously, you can't step over the code. So you need to step by individual snapshots. But this has huge benefits, especially in production scenarios. But it gets better. This was relatively simple in terms of observability. Let's up the ante a bit and talk about user-specific problems. So here I have a problem with the request. One specific user is complaining that the list on his machine doesn't match the list for his peers. The problem is that if I put a snapshot, I'll get a lot of noise because there are many users reloading all the time. So a solution is to use a conditional snapshot, just like you can with a regular debugger. Notice that you can define a condition for a log or for metrics as well. This is one of the key features of developer observability. I add a new snapshot, and in it, I have an option to define quite a lot of things. I won't even discuss the advanced version of this dialog in this session. This is a really trivial condition. We already have a simple security utility class that I can use to query the current user ID. So I just make use of that and compare the response to the ID of the user that's experiencing a problem. Notice I used the fully qualified name of the class. I could have just written security, and it's very possible it would have worked, but it isn't guaranteed. Names can clash on the agent, and the agent side isn't aware of all the things we have in the IDE. As such, it's often a good practice to be more specific. After pressing OK, we see a special version of the snapshot icon with a question mark on it. This indicates that this action has a condition on it. Now it's just a waiting game for the user to hit the snapshot. This is the point where normally you can go make yourself a cup of coffee or even just go home and check this out the next day. That's the beauty of this sort of instrumentation. In this case, I won't make you wait long. The snapshot gets hit by the right user despite other users coming in. This specific request is from the right user ID. We can now review the stack information and fix a user-specific bug. The next thing I want to talk about is metrics. APMs give us a large-scale performance information, but they don't tell us fine-grained details. Here we can count the number of times a line of code was reached using a counter. We can even use a condition to qualify that. So we can do something like count the number of times a specific user reached that line of code. We can also have a method duration, which tells us how long a method took to execute. We can even measure the time it takes to perform a code block using a tick-tock. That lets us narrow down the performance impact of a larger method to a specific problematic segment. In this case, I'll just use the method duration. Measurements typically have a name under which we can pipe them or log them, so I'll just give this method duration a clear name. In this case, I'm just printing it out to the console, but all of these measurements can be piped to statsd and Prometheus. I'm a pretty awful DevOps, so I really don't want to demo that in this case, but it does work if you know how to use those tools. Talk to Tom in the chat. He's really good at that sort of thing. As you can see, The duration information is now piped into the logs and provides us some information on the current performance of the method. The last thing I want to talk about, bring this all together, and that's tags. We can define tags to group agents together, such as production, green, blue, Ubuntu, etc. Every pod can be a part of multiple tags. Every action we discussed today can be applied to a tag, and as such can run on multiple machines simultaneously and asynchronously. This solves the scale problem when debugging. So developer observability. You can keep an observability agent running all the time, since it's designed for this case. So literally one of the top problems we discussed with debugging locally, not applicable anymore. They don't have breakpoints. Snapshots don't stop, so you will never get stuck on a breakpoint. They're secure by design, and they are read-only. So you can't even make a mistake. So, and you can't destroy your server because of stability risks. At least some of these microservices, of these services like Lightroom, support things like PII reduction, which removes private information from logs if you accidentally logged something that includes credit card information, stuff like that, or did it on purpose. They also have block lists where you can mark a specific file, a specific class, and say this file or class can't be accessed by Lightroom. And this will be blocked even from internal malicious developers who might want to collect information that they shouldn't have access to. So in closing, I'd like to review some of the things we discussed today. kubectl debug made debugging crashed pods possible. It also made it possible to debug a pod based on a bare-bone image. KoolKits made kubectl debug easier to use with pre-installed tools and sensible defaults for all of us. Debugging an application in an existing container in production is a difficult and risky process. And developer observability made deep, secure, read-only, real-time debugging at scale easy as pie. So thanks for bearing with me. I hope you enjoyed the presentation. Please feel free to ask any questions, and hopefully you asked Tom quite a bit. I couldn't keep up multitask there. It's an age thing maybe, but I'm just blaming it. Anyway, if you have questions beyond this, feel free to write to me. My contact details are here. Also, please check out talktotheduck.dev, where I talk about debugging in depth. Also check out lightroom.com, which I think you guys will like a lot. And if you have any questions, again, my email and everything are listed here. So thank you all.
Cool, Shay, thanks. Thanks for running us through this. I saw there were some questions in the chat that Tom answered. Anything else that that you're interested in? That's a question to the audience, obviously. So anything you want to know after Shai's run through of debugging in production?
This isn't a prop, real, actual tea, not coffee. That's for you.
Where will the recording be posted? I'll send it in an email tomorrow. No worries. No worries. That's an easy one to answer. I want to play with it. Yes.
Go with it. Lightroom.com/free. And yeah, Tom is always prompt as usual. Again, the creator of KoolKits. From my side, I beat you, man. It's, you don't see this here, but we sit one next to the other, and there's this friendly rivalry where I constantly yeah.
It's good. Can we debug apps deployed on Kubernetes clusters as well?
Yeah, that's the whole idea here. So everything I showed here should work in production with the caveats I discussed. So the normal debugging would have the same problems. KoolKits will work if you know the container and you can use lots of the tools that are there, not necessarily JDB or GDB or all of those, although you can use them with caveats. K8s.
I think
Tom, are you familiar with K8s?
I was assuming it should be Kubernetes. I think it was meant to be K8s. Do we need to change our app container builds?
So too.
Yeah, I think that's fine. Do we need to change our app container builds in addition to installing the agent on the Kubernetes nodes?
No, that's the beauty of it. You install the agent and it works.
Okay, so I'm just reading. Emra really meant key.
Go ahead, Tom.
K3s. Okay. How do I convince my DevSecOps to add the Lightroom agents to all of our workloads, or did I get something wrong? It's a question Michael is asking.
That's a great question. We've gone through quite a few security reviews and already deployed in major organizations such as banks, etc. This is a very secure way to inspect your servers. And actually, one of the nice things, I have an article about security in Lightroom, actually debugging 0 days. So this would actually improve your security because, for instance, in the case of Log4j recently, not so recently, December, and even the recent spring Log4Shell, we had, like, on the same day that the CV, before the CV, in the case of Log4Shell, Spring4Shell, we came out with a video explaining how you can use Lightroom to debug that, because it's a generic debugger. It doesn't need to know about the security vulnerability in advance. So you can just literally place a snapshot in the area that's vulnerable with the right condition and detect hacks actually coming in. So if someone is exploiting it, you can actually get all the data about an actual exploit actually happening. And this is something that no security tool can physically do, because they can't possibly be ready for a problem they don't know about yet. We don't need to, because we're super generic. So you can just debug the security problem, assuming you know the class or the file where the problem is occurring. You can actually get that information, which can help with the mitigation of these sort of problems. So there's that. There's also a huge article in the website about security that talks about the security Lightroom itself has, and the solutions, like I said, the PI reduction, block list, and all the other things that we offer in terms of security. About other tools, I can't speak about them, obviously. It's my familiarity is. Thanks, Tom. Tom posted the link.
Yeah, Tom already answered a couple of questions in the chat. So I think that's good. Let's say, looking at the time, we are 2 minutes over, but I think that's perfectly fine. I don't see also that many new questions. So thanks again for running through this with us, Shai. I will share the recording tomorrow in an email with your contact details. So if anybody in the audience has questions, follow-up questions for, I think, either you or Tom probably, then feel free to reach out directly tomorrow. And with that, thanks everybody for participating today.
Thank you.
And thanks for presenting, and see you hopefully at the next meetup. Have a good evening or day, everybody.
Good night, everyone.
Bye.
Thank you.